Hello everyone, in this presentation we'll talk about application of drones and open source software for mapping and visual inspection of embankment dams. My name is Daniel and I am developed a doctoral project at LENEC in partnership with New University of Lisbon. This work was developed together with my advisor Marcelino from LENEX and Sofia Gonçalves from Águas do Norte. This presentation is structured in 6 main topics. 1. Introduction. 2. Monitoring of embankment dams. 3. Using drone to map dams. 4. Using open source software to photogrammet process and 3D spatial data generation. 5. Result and 6. Conclusions. Dam surveillance and early detection of initial failure modes. It's common knowledge that from the safety, it's of fundamental importance to identify early anomalies that may grow and compromise the stability of the structure. Needless to say, some types of anomalies, such as pipe, can grow quickly and become irreversible to solve the trouble. However, most failure modes can be eliminated when identified and treated early. Using drones for visual inspection and mapping dams. In this sense, as we'll demonstrate in this presentation, the use of new technologies such as drones can be an auxiliary tool to identify and mapping the existing anomalies in dams. Using open source software to photogrammetric process and 3D spatial data generation. Why use open source software for process imaging? I would like to invite Mr. Marcelino to talk a little about the open source software. Mr. Marcelino, please.
To process the data from the drone service, we decided to use only open source software, also known as OSS. Beside the obvious, but not the most important aspect of the licensing cost, there are other aspects that make this a very wise decision. For example, using open source software, we can study the source code and adapt it to our needs. Another aspect is the possibility of installing the software in multiple machines without any licensing issues.
Below we'll show some illustrations of anomalies identified with images obtained with drones. Most anomalies can be detected on the surface of dams, such as cracks, slides, seepages, boils, erosions, trees, and bushes, among others. However, they can be identified and mapped through aerial survey with drones. Let's go ahead to see some examples of anomalies that can be mapped with drones. Sinkholes. On this slide we see a drainage problem that evolves into a sinkhole. Aerial mapping makes possible to identify as well as scale and monitor the evolution of anomalies. Erosions. In this example, we see a large erosions that are early detected and mapping with drones. Cracks. In this slide we see transversal cracks that aerial drone mapping has identified. On this slide we can see failures in the vegetation, as well anomalies grow which are indicative of wet or dry areas. Finally, we can see in this slide a big pipe occurring, but Wet areas and presence of pipe can be mapped aerial survey with drones. Normally, dam monitoring is performed using instrumentation such as piezometers, flow meters, and other instruments. However, there are many dams that were built with insufficient or inexistent instrumentation. Another important aspect of dam monitoring is visual inspection, with in turning result in checklists. However, these two monitoring modes may be not enough to represent dam safety conditions. Many anomalies that are not detected by instrumentation because the instrumentation see only a point were installed. The visual inspection requires adequate access conditions that may not exist. In addition to private alternatives, aerial drone mapping generates 3D models with high-resolution photos that precision records the condition of the structure and can work in complement to traditional ways of monitoring. Now we'll talk about the aerial mapping of the Sambade Dam. That's a dam managed by company Águas do Norte. It's built in north of Portugal and located about 1.5 kilometers so of the village with the same name and 6.5 north of the village of Alfândega da Fé. It's an embankment dam with a zone profile. The dam has a maximum height of 29 meters and about 327 meters of development. For mapping this dam, we use the Phantom 4 Pro drone, which has 20 megapixel camera, flight range of 13 minutes and distance range of 7 kilometers. The flyover were carried out at two altitudes, 20 meters for survey elevation of the crest and 16 meters for the entire area. It has possible to obtain images with a resolution of 1 centimeter per pixel. Another important aspect of the flight plan is the definition of support point in the field, which must be located over point of interest, where there are wide variation in altitude in order to verify and refine the topography and verify the precision map. We use a GPS Hyper 2 with base and hover and 9 targets that were distributed on the crest and downstream slope. To carry out this flight plan, we use the drone deploy software. To fly over an interior area of 11 hectares, it was necessary to use 5 full loaded batteries of the Phantom 4 drone, which despite the bad weather and the unfortunate wind conditions, it was possible to carry out our flight on a full morning. Now Mr. Marcelino will talk about web ODM software and open source software.
We have decided to use OpenDroneMap, also known as ODM or Web ODM, that has a friendly web-based user interface. Web ODM can be installed in a personal computer and in servers. Installation is quite simple in Linux machines using a Docker instance. We are using both approaches. In the PC instance, We are trying to customize the code to improve it to our needs. While in the server, which we can see here, the aspect, we take advantage of a power cluster with very high specifications to allow for a fast processing of our survey cases. It is worth noting that some of our surveys have more than 1000 high resolution pictures that take about 5 or 6 gigabytes and take near 24 hours of processing in this very high-end server.
Thanks, Mr. Marcelino. Now we are showing the results of the process with WebODM. After the process, it's possible to access 2D or 3D WebODM interface. In the 2D mode, it's possible to obtain the orthophotos, draw contours, lines, measure distance, and calculate areas which can be exported in a geotiff file and imported into another CAD and GIS programs. As demonstrated in the 3D interface, it's possible to view a dense point cloud and navigate to model in a 3D view, generate sections and profiles, and calculate volumes. The program also exports to point cloud in LESS, geotiff, and other formats that interface with CAD and GIS programs. In addition to visual inspection, it's possible to have a topograph recorded and perform the deformation analysis, show of the elevation map generation is in open source software WebODM. The software allows the generation as well to export the TM for the generation contour lines and generate the sections and profiles in another softwares. Conclusions. The use of aerial mapping with drones has enabled a new perspective for the visual inspection of embankment dams. As demonstrated through spatial modeling of the structure, it was possible to capture and to record the conservation condition of the dam. These records can be used for future inspections to compare the evolution of anomalies. The same technologies can be improved by using different cameras, namely those in the range of infrared or thermal cameras, allowing for detection of another anomalies and features. Thank you very much for your attention, and I am available for more information.